this lesson, we're going to combine the last 3 lessons together. So everything we've learned in the last 3 lessons. So it's problem solving involving normal distribution. So the difference with this is we're going to have to be able to convert our actual true scores into z-scores so we can find the area. So let's look at the first example. A light bulb manufacturer produces 35,000 light bulbs. From past data, the lifetimes of the bulbs are normally distributed with a mean life of 900 hours. So that's our mean is 900. And standard deviation of 50. Predict the percentage of light bulbs that will last between 825 and 875 hours. So the first thing I would do is remember mean always goes in the center. Now with my pencil, so we start with putting 900 in center because that's our mean, and I'm grabbing my pencil and I'm just drawing in 1, 2, 3. Those are my z-scores, -1, -2, -3. So our x-scores can go on top. So if we know that our mean is 900, then remember our standard deviation is 50. So the next one would be 950, then 1,000, then 1,050. And going the other direction, we'd have 850, 800, 750. Now we want the probability, or the percent of light bulbs that will last between 875, 825, 825 is about here, 825, and 875. 875. So we want how many are going to last in between there. So that's where my shading is. Highlighting. So I'm going to highlight in between those two values. So this was the 875 right there. So our charts that we have here are only for z-scores. And so what we need to do is we need to convert our two values into z-scores. So I have the value of 825 and the value for 875. Remember our formula is x minus our mean over our standard deviation will give us our z-score. We need to find the z-scores for both. So first, the z-score for the 825 value. So the x-score, the actual value, is 825 minus the mean of 900 divided by 50. Remember when we put this in our calculator, we need brackets around our numerator. So if I type this in, 825 minus 900 divided by 50 is negative 1.5. So the z-score for the first guy was negative 1.5. Now I need to find the z-score for the other value, 875. So it's our value of 875 minus the mean divided by the standard deviation. Again, in your calculator, you brackets around your numerator. So that gives me 875 minus 900 divided by 50, and negative 0.5. So negative a half. So now we can find the area in between both. So to find the area in between, which is what we're looking for, or the percentage, I'm just going to move this up a bit. We want the area of the larger, so negative a half, minus the area under the smaller, negative 1.5. So grabbing our value, our chart, negative 0.5. So negative 0.5 is a z-score. It's the same thing as negative 0.50. So I found negative 0.5. Negative 0.50 is on the end. So our value is 0.3085. So 0.3085 minus the area under negative 1.5. So again with my chart, negative 1.5 is the same thing as negative 1.50. So negative 1.5, and here's the 0. So that's 0.0668, the area under that portion. 0.0668. So we want to subtract those two areas. Oh, 0.668, which gives us 0.2417. Now it wants it as a percent. So predict the percentage. So changing that to a percent, we just times it by 100, or move the decimal 2 to the right. So 24.17% of the light bulbs are expected to last between 825 and 875 hours. So let's try another B. How many of the 35,000 light bulbs would you expect to last between 825 and 875? Well, we have 35,000 light bulbs times, if we know 24.17% of them are expected to last between that amount, we're going to multiply that as a decimal by the 35,000. So times our answer by 35,000 light bulbs, we could expect to the nearest light bulb 8,460 bulbs. Should last between 875 and 825 hours. Let's try the next question. Determine the probability that a bulb selected at random will last less than 900 hours. So remember again, we have 900 as our mean, one standard deviation away as at 950. Make it a little darker. So here's 950. And so we want that lasts less than 920. So that's going to be somewhere over here. 920, we're going to shade to the left. So remember our Z-score for 900 is 0. And our Z-score for 950 is 1. So we expect the Z-score to be between 0 and 1. So before we can find the area to the left, we have to change that 920 into a Z-score. So x is 920 minus our mean of 900 divided by our standard deviation. Don't forget brackets. Which gives us 0.4, which is exactly what we expected. We expected our Z-score to be between 0 and 1. So now that we know our Z-score, we want to the left, which is perfect for our chart, area under 0.4. So we just grab our chart, 0.4, so we want the positive, 0.40, 0.40 is 65.54%, or 0.6554. And it wants probability, and so we just keep it as a decimal for probability. And so that's the probability that it'll last less than 920 hours. So 65.54% of the bulbs should last less than that. Okay, let's look at flu virus. A study showed that the mean duration of certain flu virus was 12 days, and with a standard deviation of 3. So if our mean is 12, we draw in Z-score of 1, 2, 3, -1, -2, -3. You could draw in, we're adding 3 between each Z-score. So this would be 15 going up, and then 18, 21, and going down, we'd subtract 3 is 9, subtract 3 is 6, and 3. So we want, what is the probability to the nearest hundredth that it would last longer than 17 days? So 17 would be in here somewhere. And we want longer. Longer means greater than. So we're going to shade to the right. So the first thing we need to do is figure out, okay, what is the x-score, or z-score, for 17? We know it's supposed to be between 1 and 2. So let's find it out. So we use our formula, x minus our mean over our standard deviation. So we're looking for the z-score for 17. So that equals 17 minus our mean of 12 divided by our standard deviation of 3. Remember, your numerator has to be in brackets. So 17 minus 12 divided by 3 is 1.67. We always go to 2 decimal places for z-scores. So 1.67. So now that we know our z-score is 1.67, we can find the area to the right. Now, unfortunately, our chart is for the left. So to find the area to the right, we have to go 1 minus the area to the left of 1.67. So looking that up on our chart, 1.67 positive, 1.6 and 7. So following that across, that's 0.9525. But that represents the left, so we subtract that value from 1. 1 minus 0.9525 gives us 0.0475. So that is the probability that it's going to last less than 17 days. Okay, so you could even write this, our final, so the probability that our x, because our true value score is greater than 17, was equal to 0.0475. All right, next one. So again, same problem, 12. I'm just going to draw in these 1, 2, 3, 0, -1, -2, -3. And our true value scores, so adding 3 to each one, go to the right, 15, 18, 21, and then 9, 6, and 3 again. So we want the probability that it's between 13 and 15 days. So you need to find the z-score for each. You could probably figure out the z-score for 15 without even using the formula. So the z-score for 13 would be 13 minus our mean of 15 over 3. So in your calculator, remember brackets. Use negative 0.67. Negative 0.67. Remember, we go 2 decimal places always for z-score. So that's the z-score for the 13. Should that be negative or positive? Our mean, oh, I made a mistake. Right? Our mean was 12, not 15. So 13 minus 12 divided by 3 gives us positive 0.33. That's better. Now we do the same thing for 15. So 15 minus our mean of 12 divided by 3 gives you 1. And you could also just see that. It landed perfectly on 1. So we want the probability that our z-score is between 0.33 and 1. And 1. Okay, so that's area under 1 minus the area under 0.33. The area under 1, grabbing our sheet, so 1.00. 1 point, so we don't need these ones. 1.00 is 8413. Minus underneath 0.33. So again, same chart. 0.33 is 6293. Decimal 6293. So subtracting those two values, that gives us 0.2120. the probability that our score was between, so X is our actual days, a flu between 13 and 15 days, that it'll last that long is 0.2120. All right, next page. Now it said the answer, sorry, you wanted to the nearest hundredth, so both of the, I would actually answer A as 0.05 and B as 0.21 because it wants the nearest hundredth. Okay, next page. From extensive testing, an appliance distribution company knows that the average life of a toasty toaster is 4.2 years. That's our mean. The standard deviation is 0.65. And the data is normally distributed. The company does not want to replace under warranty more than 8% of the toasters that are sold. So it does not want to replace more than 8%. What warranty to the nearest tenth of the year should the company offer? So it's saying that it will replace 8%, 8%, but no more than that. So if we shade this, we're saying that our area to the left will do, the company will replace up to 8%. So what would that be as a decimal? 0.08. So what we need to do first is find the Z-score that represents 8% to the left. So looking at our table, what's the closest value? So obviously we need to go to the negative Z-scores, under 50%, and look for 0.08. Now, if you look at these two values, 0.0793 and 0.0808, which one is actually closer to 8%? And the closest one is the first. Okay, 0.0793 is closer than 0.0808. So we're going to go with the closest value. And so that Z-score is negative 1.41. So that's the Z-score associated with that area. So, writing that out, we were looking for the area under Z1 we knew was equal to 0.08, and so Z1 is equal to, or Z, negative 1.41. Now it's asking for, okay, well, what actual value does that represent? We know the Z-score now, we want the actual value. So we're looking for X. Remember our formula of Z is equal to X minus our mean over our standard deviation? Well, we know our mean, we know our Z-score, we know our standard deviation. So our Z-score is negative 1.41 is equal to X, what we're looking for, minus our mean, which was 4.2, divided by my standard deviation, which is 0.65. So first step, multiply both sides by 0.65. These are gone. So my calculator, I have a negative 1.41 times 0.65 is negative 0.9165. Is equal to X minus 4.2. And our last step is add 4.2 to that value. It looks for our answer to the nearest necessary year. So I have 3.28. So going up here, 3.28 is equal to X. It says what warranties the nearest year? Now if he goes 4 years, would that be higher than 8% or lower? That'd be higher. So to the nearest year, he should warranty 3 years. And that's our final answer. That's our final answer. Okay, another similar problem where we see a percent. So often when we see a percentage value, then we're working backwards, right? We're looking up our Z-score. So it was found that 62.3% of the shrimp harvested at Shrimp Harvest Festival had a mass more than 135 grams. More than 135 grams. If the data is normally distributed, and if the mean mass of the shrimp was 146, 146 is the mean mass, determine the standard deviation. So our standard deviation is unknown. We know that 135 grams is less than 146, and we know 62.3% were greater, so that's to the right. So all of these shrimp added to 62.3% of the shrimp. So this value here is that 62.3%, or as a decimal, 0.6230 is to the right. Now remember, our chart's always to the left. So we need to figure out what's this value here. How do I get the area to the left? Well, the area to the left of this z-score, we'll call it z. The area to the left of z is going to be 1 minus the 6230 because that's to the right. So grabbing your calculator, we're going to figure out what that value is. 1 minus 0.6230 is 0.377. So the area to the left of our z-score is 0.3770. So grabbing our sheet, we can figure out our z-score if we know that area to the left. So 0.3770. So where is that? Scrolling down. 3770. The closest is 0.3783. So that would be negative 0.31. So that's our z-score. So our z-score is negative 0.31. Now whenever we're looking for standard deviation, we're going to use this formula. Z equals x minus our mean over our standard deviation. So our z value is negative 0.31, and that's equal to, what was the x-score at that point? It was 135, minus the mean was 146 over our standard deviation. I can simplify my numerator there. 135 minus 146 is negative 11. We want to solve for a standard deviation, so our first step is to multiply both sides by standard deviation to get it off the denominator. So negative 0.31 equals, times our standard deviation equals 11, or negative 11, and so we're going to divide both sides by negative 0.31. So divide that by negative 0.31. And that gives me a standard deviation of 35. It says to the nearest tenth, 35.5. And unit here is grams. The marks of a large number of students have been represented on a standard normal distribution curve. The value given represented the number of students in each area. Now, really quickly, if 1250 is above 0, and our curve is always symmetrical, how many total students are represented by the area under this curve? Well, if we know one half is 1250, then the other half should also be 1250, so that would be 2,500 students. 2,500 students, because we know this half is 1250, so this total half should be 1250 as well. Okay, so that means we can figure out how many students are in this small little area to the left. How? Well, 1250 minus 452, because we know the half should also add to 1250. So 1250 minus 452 gives us 798 students. So it says determine the value of Z1. In order to figure out Z1, we need to know a percentage or an area, a decimal value. If we know there's 798 students and we know there's 2,500 total students, can we turn that into an area or a percentage? Yes. 798 over 2,500 tells me the area under that portion is 0.3192, or 31.92% are to the left of Z1. And so we know, in order to find Z1, I know the area to the left. I'm just going to use my chart. So 0.3192, 3192, there it is perfectly, negative 0.47. So our Z-score is negative 0.47. And that is it. And that concludes this lesson.